Okay, welcome to week 3 of Diploma for Materials and Methods. We're actually only into our second lot of slides, but that's fine. Yeah, we've got plenty to, well, a little bit of gap later on in the semester, so we can sort of cram things up a little bit with that. Late arrival. Joe? Yep. And yeah, also my apologies. Not that I've sent you guys. I haven't sent you guys the link for the videos of the class recordings yet, no, but I've done that for the externals because that's their really their only link to the materials apart from Moodle. But yeah, particularly to the externals, I apologise. Last week's video was just a stuck screen, so it was just the first screen shot for the video was taken through the whole video, so I apologise about that. Hopefully it doesn't happen with this one today. Not sure what causes that. Well, but hopefully it's not a common issue. So we've covered consultants and authorities. Basically what we need to do before we, before we start thinking about a project and working through it. Today it's about that initial getting onto site and working out what we can actually do on the site. So this is design considerations. There will be some revision in this section from what we've covered in the first week, particularly in regards to site identification, so titles, etc. Some interesting buildings about the place. A couple of those I know, a couple of them I don't. Does anybody know any of these buildings? Has anybody seen any of these buildings about? What's that?
The bottom left's the Great Ocean Road.
Yeah, bottom left is the Great Ocean Road. That's down near, is it Torquay, is it? Or Apollo Bay there?
A bit further along,
Yeah. You don't normally get that view of it. It's normally like from the road. You see this thing jutting out on the hillside. Yeah, amazing piece of architecture. That and also an interesting one to get through council. The other one up there that I know of, actually I don't know the address of this property, but that was designed by Max Pritchard. So he's a very busy architect in South Australia. Does some fantastic stuff. Also I guess possibly an achievement of planning. That's the type of thing you can't get in many locations. One of the issues with doing something like that is for any on-site wastewater, or under the guidelines, you're not allowed to have a building within 30 metres of a listed watercourse. So here we have a building spanning a watercourse, but I suppose that watercourse is not one that's listed on the state government maps as a significant watercourse. So typically not an easy thing to get through planning or council, but yeah, very very innovative approach to building on an interesting site. Top left there, don't know the building, but I guess the characteristics of that are that it has significant round earth walls. Is that more as a feature than as a structural element, although they may well be load bearing. And significant skilling roof for a large elevated outdoor entertaining area for that. And it's one down the bottom. I don't know, some review at home made. So site configuration can affect building design such that we need to consider the size of the block. So certainly the size can definitely impact on that. And also when we're looking at size of the block, we also have to look at particularly the council-wide objectives in there. They often have listing for requirements for private open space and setbacks. And so once we take into consideration setbacks from street frontage and requirements for private open space, that can actually be very restrictive on the actual footprint of our building that we can do. So with a very restricted footprint, possibly we need to go up. Yeah, possibly up several stories. So the shape of the block, whether it's long, hammerhead, L-shaped. So does everybody know what a hammerhead block is? Or does anybody know what a hammerhead block is? Tell the rest of the class. No? Yes? Yep. Oh.
A hammerhead is where you have a long driveway down the side and a block at the rear, so 2 blocks, one in the street front and one at the rear.
Yep, exactly. And anybody else? What sort of scenario gives rise to a hammerhead? Why do we start seeing those hammerhead blocks around now?
Yeah, it should be like in a narrow shape and then to spread it like a shape of hammer.
No. Typically, it's a long, skinny driveway and then a square block at the rear. Holly, you?
I was just going to say subdivision of a block of land.
Yep. Yeah.
Because I'm looking into it at the moment.
Right. Yeah. Looking into doing a subdivision.
Yeah, maybe.
Yeah.
Well,
Yeah.
it's too much land, too much gardening.
Right. Yeah. So the hammerhead arises because I guess previously Adelaide metropolitan area was dominated by what was known as the quarter acre block. So the 1,000 square metre block of land that a lot of people don't really want these days for exactly those sort of reasons. Just a lot of water usage, a lot of maintenance, etc. for not a lot of gain. And they can be very, very valuable, particularly in inner areas or areas that are a little bit more densely populated and popular. 1,000 square metres can easily be split up into approximately 2 500 square metre allotments, still, reasonable yard size. But that extra 500 square metres can be worth quite a lot of money, sort of the $300,000 to $400,000 mark or upwards if you're in the urban areas. So that's why people do that and create those. So there's a lot of that happening around. We need to consider slopes or gradients. So slopes can be a major determinant of what we build, and also once again within the specific zoning requirements or the council-wide objectives, that can really dictate whether or not it can actually be built upon. So one notable example is within Hills Face zone. There are several councils that have Hills Face zoning, but typically a characteristic of Hills Face zoning is they do not like to have anything protruding significantly from the land, so on poles, etc. And it's certainly discouraged that when you cut into the land that you're not building on the fill. So if we've got a block of land that slopes like this, for example, we want to get a house onto that. Council saying, well, we don't want, so we do a driveway like that and then elevated house out here, funky roof on that. Council don't really want that type of thing because that stands out extremely well against the Hills Face. So they prefer that you sink it in. So we go through the process of cutting and filling the land, but council says also we don't want you building on this fill section. So because the risk we run with a scenario like that with the fill is of course the subsidence and the settling and collapse of that portion there. Yes, we can auger through here put in some piers and lock into that stable ground. But there are still, particularly in really steep slopes, with the added weight of this soil here, there can be still some subsidence and slippage of soil like that. So typically councils don't like that either. And so all of a sudden, that slope has left us with a very small building footprint to deal with. And possibly we need to think of something like, some sort of stepped form of constructions, several stories, that sort of scenario.
What if you did a upside down pyramid on that hill?
Possibly. I guess that is a very interesting approach. It's not
Without going into the hill at all.
Yeah. I've only ever seen one upside down pyramid house. Well, no, it wasn't a house, it was an office building in Japan. But have you seen
Yeah,
upside down?
it was on, was it Australia Design the other night?
Yeah.
And they just had the driveway down the bottom, strictly sand, and then they just built on top, and the living was on the top,
Yeah.
and there was a little cutaway at the top. So it saved money. There's no construction person wanted to touch it because the slope was too steep.
Yeah.
So he decided to build an upside down pyramid where you'll save money, and the construction, like earthworks, was very minimal.
Yeah.
And there was a solid base.
Yeah. So the place that I saw in Japan, I can only assume what was underground from what I saw above ground. But so plan view, of course, you get a very dry pen here. I should grab another one. In plan view, very square type of plan. That's your upper level, and then you have your major structural elements that run through like this, and then in elevation, we've got something happening like this. So your major structural elements running through, and then this is your ground level here, and they continue on in some fashion in this way into the ground to lock your pyramid into the ground, and then obviously on a sloping side that's doing something like this. How they're dealing with that, I'm not sure or what. But no, so that was on Grand Designs.
Yeah, that was in New Zealand. Actually.
New Zealand Grand Designs. Yeah. All right. Interesting one to watch. I didn't get to see that one, but yeah, possibly a fantastic approach too.
Yeah, he took the build on by himself.
Yeah.
Because no other company would touch it.
Right.
The slope's too steep.
Yeah.
And he just contracted people out, and sure enough, they ended up with it was only going to cost about 500,000, it cost $1 million a year.
Right. Yeah.
Yeah, very
Cool. Yeah. So it may, steep slope may end up leaving you with the option of a pyramid house. Rivers and creeks flowing through. So yes, I mentioned the thing about on-site wastewater. So our main constraints with that are no building within 30 metres, 30 or 35. I'm not quite sure off the top of my head, but let's say roughly that 30 metres. So no building within 30 metres. No septic soakage or ground application within 50 metres of a creek. So that can definitely dictate what you can build there. Or there was a place at the Basket Range I looked at once that was for sale. Turns out that place is completely unbuildable because there was not actually a location far enough away from the creek to be able to do the on-site wastewater scenario.
Was it up for sale for residential?
It was, yeah, and all the marketing was, build a dream home here, blah, blah, blah. Yeah, turns out it's actually unbuildable.
Like someone didn't buy, hopefully no one bought it, but didn't look into that.
No, the person that bought it was actually an adjoining owner who has a decent sort of farm, and he bought it just for water access to that creek, so for the riparian rights to be able to take water. So no, so it was a story that ended well.
Yeah.
But yes, imagine, yeah. So these are things that you need to be aware of, and also any retaining walls or structures. Retaining walls can be relatively cheap. They can be incredibly expensive. I think there was a retaining wall that we had to reinstate in Springfield. I think that so reinstatement is going to be, of course, much more expensive than the original site works because you've got to deal with existing structures, etc. But that was around $150,000 to reinstate that wall. It's an incredibly high wall, and Springfield, I guess it's worth it. You've got the land values there in excess of probably $1,500 a square metre, so it's worth it, but it can, it's an expense that you definitely have to consider. Site configuration, factors that affect construction costs. So earthworks can be very expensive, particularly bringing in quarry rubble. Also, depending on the type of soil you've got, some areas will need to be filled with quarry rubble. A ton of quarry rubble doesn't go very far. A ton is 0.6 cubic meters, so that's not actually, that's a relatively small sort of pile when you're packing things down. At $30 to $40 a ton, that cost stacks up very quickly. So, but also in the actual machine hire or operator hire and disposal of soil, that can be expensive at times as well, depending on your contacts. Yeah, so earthworks can be incredibly expensive, but particularly when you've got to bring in quarry material. Retaining walls, as I said, can be very expensive. Piers also, one scenario I know of, I'm trying to think of the name, it's just near Walkerville, where the ABC building is. They're doing piers for a building. They were pouring concrete in, and they just kept pouring concrete because they hit some sort of cavity underneath. You run those sort of risks with piers as well. Yeah, so that's not an ideal situation. Underpinning of existing structures. So sometimes when working close, like in the bottom right hand diagram there, when you're doing site works right adjacent to existing buildings, you've got to stabilise the adjoining buildings. And actually, I'll get into that a little bit later. So records, documents. You want to identify the site location, street, and lot number. You have to avoid building on the wrong lot. Of course, that sounds like a no-brainer. Sometimes these misidentifications happen. I had an issue with a block over in Kangaroo Island. There was a whole series of blocks in bushland there. Initially, I identified the wrong lot, but that was fairly quickly rectified when we were doing the survey. We realised, no, it's the one adjoining that, because it's very difficult in some scenarios with features and missing lot numbers and missing pegs, etc. So it can happen very, very easily, particularly in those sort of scenarios. Certificate of title, so you should all be familiar now with a certificate of title. The lot number should be able to find the registered proprietor, and here it says description of the land, so that relates to the legal description of the land. You should be able to identify easements on a property and know what encumbrances are, like contracts which restrict things like there's developers encumbrances like colour, style, profiles, fencing, facades, etc. But there's a bunch of other encumbrances you are now aware of, liens, so a financial debt against the property. And then the survey plan image of the allotment on the certificate. Boundary angles, lot number, and once again easement and orientation. Just this last week, I had an interesting easement crop up. It was it was an easement for access to water storage. It took a little bit to work out exactly what this easement was for, but it was the scenario whereby an allotment had been carved off the back of an existing property, a property in the hills, and the existing property had a header tank up on that portion of land, and so they wanted that head pressure for their water, so they pump up to that, like from the bore, and then that header tank supplies them with pressurised water without them having to run a pump. So initially when they did that carve up, they produced an easement for on that particular property, and so now the people who have bought that portion of land are restricted to what they can build because they can't disturb that header tank or the associated infrastructure. Or there's a bit of a query about, okay, how much of that easement do they actually need for the infrastructure for running the pipework, etc. So yeah, but that was interesting easement. But you get some odd easements like that all the time. Records and documents. So you should all be familiar with zoning, council zone maps. So the zone maps we can find from SA Map Viewer, and the associated documentation on Planning SA. Services. When we look at the allotment, we have to locate the existing services. Does it have mains gas? If it has mains gas, well then that may dictate what we end up doing in regards to hot water services, cooking facilities, etc. Does it have mains sewer on the street? If not, that will dictate what we're doing on site in regards to on-site wastewater. Does it have telephone or NBN existing or not existing? That may be a bonus. If it's not, then you can get fibre to the premise, not simply fibre to the node. Is NBN going to be available in that area? Is there any underground power at the property, running under the property? Had an interesting scenario with one where there's consumer mains running under this allotment without an easement to it, and the council have been a bit lax in the initial development approval for that, and not given stipulations for people providing the land that they have to provide electricity to their dwelling through another means, not through the block subdivided. And that gives rise to interesting scenarios like where we have underground power, no easement. What are the rights of the various different allotment owners in that regard? Stormwater. How we deal with stormwater off the site and where that's going to go. Once again, person I know had a very interesting scenario with a drainage easement at the rear of their property. So for the stormwater for all of their neighbours was running through their property. They wanted to encroach upon that easement, but it meant locating the pipes that ran through there, and then there was a whole bunch of headaches with that because pipes are broken, etc., and decommissioned and things like that. And grey water, so on-site wastewater, how we deal with that if that's going to be an issue. So a couple certificates of title. The one on the right there with the particulars blacked out, that is your modern certificate of title that you will get a printout from the Lands Titles office, or you'll get it as a PDF sent to you from the Lands Titles office. The one to the left, that is an older title. It's not a really old one. We've got a volume of 4062. That's not a really old volume. So on the right hand side here with the modern title, we've got a volume of 5100. But that 4062 is not a really old one. But that shows, the one on the left shows the original certificate of title in paper form and how that appears. So it gives the legal description up here. Yeah, I'm not sure. So we've got some names, both of number 506 Regency Road, Broadview, etc. So this is the registered proprietor and allotment 3, section 308, and 100 of Yatla, laid out as Holden Hill, deposit plan 4835. So that's our legal description. So registered proprietor, legal description. And then here are our, our registrations of transfer. So it shows the the selling of that block of land, and then mortgages placed upon that title. And here we have a very small survey plan image showing the allotment. It's a fairly simple one. This is a larger survey plan image, not typically associated with the title. So this is deposit plan 1011206. So that deposit plan shown up here in the top right hand corner. So that's the broader deposit plan for which, let's say, that previous title is part of. I'm not sure if those numbers match up. Have a quick look. No. So it's a different allotment. Oh, this one. That's file plan. So file plan, deposit plan, essentially no difference. Well, actually, to be honest, I don't know the difference between file plan and deposit plan. Never seen the difference between the two. But yeah. Does anybody know of any differences between deposit plan and file plan? It's not something I've ever researched or needed to research. So this is our broader deposit plan, and this can be really handy for understanding things such as what a particular easement is doing, where it's going, why it's in place. I was trying to zoom into that a little bit better, but what we have along here, we have easement B running at the back with all these blocks. You can be fairly sure that easement B is an easement for drainage. Well, that's a typical appearance of an easement for drainage. Running along the rear, I imagine these allotments are on the low side of the road. This is the high side of the road. Here we have a detail of the corner here for Carruthers Drive and Milne Road. So Carruthers Drive and Milne Road just here. So we have the detail of this corner here is shown over there. And we have easement A, Rose Crescent. Where do we have Rose Crescent in there? So we have easement A. Any idea what easement A could be? So we have an easement over lot 63 here and into allotment 116. I assume that will be once again an easement for drainage. So we have this long easement along the back of those ones there, so that indicates the likelihood of these being on the low side of the road, and also for 115 and 116 being on the low side of the road, they would want to be draining their stormwater through to here. 115 doesn't actually have any development happening there at this stage, so it doesn't require an easement drainage. You can drain stormwater out that way, but number 116 certainly does. So that's possible. Another survey plan image. So here we have Range Road South and North East Road. Does anybody know that area there, or think of where those two roads join? That's up at, I think the area is called Houghton. So if you follow North East Road just up into the hills, yeah. Oh, was it? If you head, so you get right up to the top of the hills there, where you got Range Road South. If you go left, you're going down into Lower Hermitage on the right hand side there. I think it's Houghton, and then it goes. You can go further down Range Road South, it takes you to Parramatta. We have quite a wide, so an easement of 5.26 metres that runs directly across those two allotments. Any ideas what that easement could be? Underground sewage. Any others for underground sewage?
Maybe telephone poles. Wait, is that what they're called?
Well, yeah, I don't know them. Yeah.
Would they go through? Like, is that what they're called? Telephone poles?
There are poles for telephone, although typically that's all run under the ground. but
Power lines above.
power lines, yeah, that's probably what I'd put my money on. Power lines, an easement of around 6 metres wide or 5.26 metres, cutting directly through something in a straight line. That, to me, that looks very much like power lines running fairly indiscriminately across several blocks. So that may be a major constraint for building. It may not, depending on the location of your poles. If you want to get information about that, contact SA Power Networks, and they will either have somebody in there that can give you advice about that, or they'll put you onto a person called the Office of the Technical Regulator, who you speak to in regards to the nature of that easement. Seen that one? Delamere Road and Rental Avenue. What is that? So in the township of Netherby. Netherby, that's just up here, Mitcham sort of area, isn't it? Yes. No. Yeah. So here another deposit plan image. Was it actually? What is it? This one, I think this one's in. We got, yeah. So we've got feet. So this one's in feet. And when you're dealing with old titles, some of the titles, some of the survey plan images have all been redone into metres and millimetres, or possibly everything's been redone now. But it wasn't all that long ago when I was working with older titles that was doing a lot of conversion from feet, inches, roods, perches, yards, etc. into the metres. So that's something you may need to do as well. Typically though, they do have, well, up here we've got a scale, but also with a lot of these old titles, when they were those survey plan images scanned in to the Lands Titles Office system, they put on a conversion there for converting yards into metres. So before you go on site, it's good to get a checklist of everything you need to have a look at on site. Get that in order. Things you may want to see, because it can be very time consuming to go back onto site. To survey the site, you can use survey drawings, or you can gain your own spot heights there. And the soil reports, that happens in the formation, or that happens in the form of a bore log. So a soil sample is taken, and then a bore log is done from that. So this is certainly a very American-looking scene. We've got a very big truck and a baseball field in the background. So this sort of rig, I don't know if we use rigs like that in Australia for taking soil samples, but typically the ones I've seen are just on the back of a Land Cruiser ute with a big hydraulic-driven push rod on the rear. Although I've also been to the site where we had to take soil samples within the hallway of an existing building. So take up the floorboards and do soil samples within the building. That was done by a two-stroke motor-driven ram with a push rod. So the push rod put it into the ground, ram it down with the motorised ram, and then join another one on. Just keep going like that, and then set up a tripod above that with a winch it back up, take a piece out, winch it back up, take a piece out, like that. So it could all be done in the hallway of a building. So that's a way of doing it in restricted areas. So checklist: prepare before site inspection. Conduct a detailed survey of the site. Locate features on site. Significant trees. So any large trees, or trees that you consider significant in any other fashion, whether that be possibly they're listed by council as significant trees, or considered by the owner or your client as being significant trees wanted to keep. Also, it's important to and it's certainly not something I have a skill in, but document the species of the tree, because some engineers will want to know that, and they'll want to know the height and the width of that tree, but they'll also want to know the species of that tree. The reason they want to know the species is because that dictates significantly the amount of water those trees draw from the soil and how much impact the location of that tree has on the footings of the dwelling or the proposed dwelling. So if you know your species of tree, that's definitely very beneficial.
Would the age of the tree make it significant or not?
Typically not. Typically it's about the size of the tree and the style of the tree. You want to know location of sewer and how you can get to that. You want to know about fencing, and then also whether there are any survey pegs on the block, and whether those fences are actually in the right location or not. It's not too uncommon to have fences that are actually in the wrong location, not directly on the boundary. You want to know about buildings and other structures, or any previous buildings and other structures. Certainly you need to know about any rivers and creeks, potholes and mounds. Anything else that we might want to have on our, I'll keep going through this. So we've got contour plan. You survey and prepare a plan by taking spot levels, and then you do your spot levels in a grid, and then you can do your survey plan from the spot levels in the grid. Although there's also, for larger surveys now, technology whereby it's levels that ping to a GPS, and so you can just walk around taking levels and then input that data into CAD, and it produces a survey plan image for you, or a contour plan for you. Anything else we might want to check out on site? Any other ideas for things to put onto our checklist?
Nearby power lines and power sources.
Yeah, exactly. Yeah, it's a great one. Very common one. Anything else?
Nearby roads.
Yeah.
Like setbacks.
Yeah. And noise, etc. from roads as well. Any other ideas? Any other things we might want to add to a list?
Heritage sites.
Yeah. Whether there's on that property, whether there's any heritage listing, or whether the street has a particular heritage character to it, and whether that's going to impose any restraints on what we're doing. Any other ideas apart from Flynn? Another one I look for. We've got buildings and other structures. I'd certainly be looking at joining buildings and what's happening there in terms of overshadowing, or whether your structure is going to look into somebody else's backyard. We've got significant trees. I'd also look for older stumps as well, and whether we have, certainly evidence of termites there, or they have to do termite protection for all buildings, but stumps, whether there's going to be anything that comes from that, and excavation and removal of those. I look for things such as underground power that might run to neighbouring properties as well. I think that's about it. So here are some contour plans. They're really a bit too small for us to see there. So with site inspection, an important thing to consider, particularly on in hills type developments is site access. How are you going to get the materials up there? And how are the trades going to do their work up there? So if you've got a really tight access, possibly a trussed roof is not the thing to do, because you've got to get large roof trusses in there somehow. How is that going to happen? Some forms of building require that you get a crane in there. Are you going to be able to get a crane on site? That can certainly be an issue. Storage. Locate an area for storage of materials, site huts and sheds, amenities, sheds and containers. Are you going to be able to get a shipping container in there? Are you going to be able to get any other site huts and so on in there? Look at existing features, demolition or removal of existing structures. That can be, the demolition and removal can be relatively expensive of a structure. So I think just sort of ballpark figure, you're looking at $10,000 to $15,000 to remove a relatively small building. So that's something that has to be considered. Tree and plant removal. In some scenarios, the felling of trees is very quick and easy because you can just cut them from the base and drop them in whatever direction you wish, and it's not incredibly expensive. But if it's a scenario whereby you've got existing structures around or existing vegetation you want to protect, and you end up dropping a tree, starting from the top, working your way down, so getting in a team of arborists to do that. In many scenarios, there's not a great deal of change from $4,000 to $5,000. So that per tree, that is. So that can also be incredibly expensive, depending on the scenario of how that tree's being dropped and what you've got around it. Removal of fencing and vegetation to access to site. One major consideration of particularly building in the hills is your CFS approval. Yes, you have to have the CFS approval for the CFS access to the site, but also they would typically state that, say you've got a property that's full of olives, they'll say you've got to remove all of those olive trees from the site. That can be, a massive job to do. Olives are not super easy to remove. Take a lot of work. Or they may stipulate that you've got to clear native vegetation within a 30-metre radius of the building site as well. And then, so that's an expense in doing that, but it's also an expense of, under the Native Vegetation Act, you've got to pay compensation. I'm not sure exactly who the payment goes to, but you've got to pay for the compensation of removal of that native vegetation to enable the offset of that native vegetation elsewhere. So that native vegetation so they replant trees in another location. So great scheme, but it has to be paid for. So that the removal of vegetation around your house site also comes at an expense through that.
How do you find out about that? Like, is there a formula with somebody? Like, how do you know who you pay to do that?
I haven't looked into it myself, so not sure. I guess probably a good place to start is with the council, because typically councils have a decent amount of, so councils deal with that on a regular basis, and they would know who to contact straight away. If we've got a little bit of time later in the lecture, we can have a quick look online to see who we have to pay. I've never had to research that myself. So removal of fencing and vegetation, access to the site. Right, site inspection, adjoining properties. Record the buildings on the adjoining properties and at the boundary, and prepare a dilapidation report. Does anybody know what a dilapidation report is? Can they tell the rest of the class a dilapidation report? Anybody who's got an idea of what a dilapidation report would be? And why we would do that? So, dilapidation report, that details the condition and any faults with any adjoining structures or any indication of faults with adjoining structures. So the reason we prepare a dilapidation report is to ensure that later on we don't get adjoining owners or adjoining neighbours saying, during construction, you're ramming in these piles caused all this cracking in my house, and I'm going to sue you for the repair and reinstatement of that cracking in my house. So we want to ensure that we know the condition of all the buildings and structures around, so that it is a clear-cut decision later on who is responsible for any repair or reinstatement work for adjoining properties. So things to look out for there are obviously any faults with buildings that we can see, but also things such as minor things such as cracking in curbs, cracking in footpaths. It can be indicative of soil movement in an area. We'll want to be looking at any evidence of cracking or movement in footings of adjoining properties, and then also detailing age and general condition of all features for all adjoining properties. I will quickly have a look. I've seen previously a dilapidation report online. I'll just see if I can grab one now. Well, here we have some things of, when it comes to a dilapidation report, what type of things are we looking for? So here we have separation between two building elements, which is indicative of soil movement, but it's also indicative that there's an issue with that building initially before construction. So looking at things like this, but this scenario, okay, we've got cracking through a footpath there. What is that showing us? What is that telling us? Subsidence of bitumen in a road, and that is, well, it's not very, or doesn't appear to be very recent subsidence in that bitumen. What is that telling us about the site, the adjoining site? I'll scoot back, see if I can quickly find an example of a dilapidation report. So here's a sample of a dilapidation report. So contents report. So also, I guess, decent sort of exercise in report structure. So report structure, headings, subheadings, and numbered subheadings to relate to contents. So many photographs taken of the buildings. Inspection was carried out 23rd of November 2009, weather at the time was overcast and cool. So making note of their inspection time. So looking at things, so as simple as a crack of up to 2 millimetres in width is evident to the council curb edge and the council layback drive.
Is this a legal requirement?
Not always, but it's a legal protection.
Okay, because
So,
I've never actually seen one with a couple of building processes. I've never seen no.
Yeah, and you can and if you're confident that the works that you're carrying out are not going to result in any damage to adjoining properties, then you can go, okay, well, it's not worth us putting in the cost of getting a dilapidation report done or conducting a dilapidation report yourself for that. But if you are working in a scenario where you fear that there may be some issues that arise, particularly in highly very dense areas where you're working, well then the dilapidation report is certainly worthwhile. So but it's a legal protection. So taking note of things that would appear to be certainly very pedantic, but evidence of existing issues. So the step between the bitumen and the concrete paving, because bitumen and concrete react differently with soil subsidence and heave. Noting the fence, condition of the fence, missing palings. Once again, cracking, evidence of soil movement, existing soil movement, and existing cracking. And also a good way of documenting the size of cracking as well, to have a ruler or a crack width identifier. Use that in your photograph. So rather than just your giving your written description of the size of the crack, you can document that evidence photographically. So not a whole lot in this dilapidation report beyond general evidence of small amount of site movement. So that's the dilapidation report. Look for services: water meter, sewer, telephone, power lines, gas, groundwater, stormwater. So 4 categories of design principles. So building design, what it's going to look like, what the shape is, how it's going to function. What are your types of materials? How, in regards to cost, functionality, appearance, aesthetics, energy efficiency of dwelling and appliances. So that's tied in with the materials that you choose, the orientation you choose, and how the occupants behave. So what the occupants want out of that building, how they live, how the building can best suit their living style. So building design has to comply with the building regulations, so the National Construction Code has to achieve a 6-star energy rating. And so energy ratings are determined by computer programs such as First Rate and NAPers.
So do you sort of like subcontract that out, or do you do that
Yes,
yourself?
you subcontract that out. You can do it in-house as well. It's been a while since I've done this, and it's all changed since. Previously, I only had to do the energy ratings for buildings in New South Wales. In fact, I can't even remember the program I used for it, but we were able to do that one ourselves. So, because you input all the information, and then that tells you, what upgrades you need to do, be it upgrading the glass or specifying curtains or awnings or things like that. But typically that is something which is outsourced. So people outsource that work. So an important consideration for building design and energy, well, just the comfort of buildings, but that relates then to the energy efficiency, because it relates to the inputs of energy to keep that building warm or cool. It's the orientation of the building. So living areas facing north, and bedrooms facing south. Typically we want our bedrooms to be cool and our living areas to be warm. So to achieve optimum use of solar radiation. I think, does everybody know how that works? Yes, no? So maximum window areas to the north and no or fewer windows to the south, east and west. Patio and courtyard to the northern side, so it provides shade in summer only, so it's high enough to provide shade in summer only. And also a system like a slab on ground gives the building lots of thermal mass. Thermal mass can be a benefit or a curse, depends whether it's used correctly. So when used in conjunction with proper orientation, getting lots of sun onto that concrete slab during winter time, and then no sun on that concrete slab during summer, that thermal mass is being used very well. Thermal mass can certainly be a curse, particularly I live in a very old cottage with walls about this wide. If we get a really long hot spell, after that you can't cool it down. It is, the building just stays hot, and that's where thermal mass can be a curse. And likewise to warm it up as well, it takes decent input to warm it up. But where you have a scenario, particularly of a slab on ground and then lighter weight construction, you don't have the thermal mass in your walls. You've just got it in your slab, and then if you're dictating when that sunlight is hitting that slab, that can be using the thermal mass very well. Another very important aspect is to provide cross-flow ventilation. So enable the building to be opened up on a summer's evening to exhaust a lot of the heat that's built up throughout the day. We're blessed with typically breezes from the southwest off the ocean here in South Australia in the evenings, and to have a building which has cross-flow ventilation going, on your windward side of southwest and northeast in the other direction, enabling you to ventilate or exhaust all that heat in the afternoon is a fantastic thing. Roof and walls, and I'll also add to that floors, insulated. That does play into the design. It plays into the design in determining how much space you have provided for insulation in your roof and walls and floor, whether you can get a high R value of bats. But there are other ways around that cost money to have an insulation with a higher R value that has less thickness, but they're typically much more expensive. And also in South Australia, typically we want light colours for roof and walls, because dark colours absorb a lot of heat and don't reflect the sunlight, so in summertime it can heat up. We can produce sun angle diagrams to look at how a building is going to work with its orientation, or this can also be done throughout with drawing programs as well, modelling the location of the sun at certain times of the day, at certain times of the year, to work out how that best works with our existing vegetation or proposed vegetation. So this is a diagram showing our sun angles in summer versus winter, and how that works with our building. Here we have what's called a clear story building. So we've got the clear story window up in this section here. So in winter time, these windows are facing north and allows sun to pour right into the building, and the inclusion of that clear story window above enables light to pour into the back of the building as well. That brings warmth brings solar radiation, and that warmth is trapped within the house to a certain degree. But then in summertime, we have adequate eaves to ensure that when the sun is high in the sky, that the eaves shade the windows entirely, so we don't get any sun onto those windows. And here is a good rule of thumb, I think. I can't remember the name of the source of this information. This is for Brisbane. I have seen a diagram like this for Adelaide as well, where it's, I think, is it 34.5 degrees south Adelaide. So we need we can deal with slightly wider eaves than that, because our winter sun comes at a lower angle. Also, the thinking about where or what trees to plant. So deciduous trees you plant to the north, so they provide shade in summertime, but they've lost all their leaves in winter, and the sun can pour through in winter time, giving you plenty of access to sun. But evergreen trees to the west. Typically, you don't want that western sun or that evening sun pouring into your building and warming up your building. So here's some examples of solar access and ventilation. So large, wide window. Is that? Oh, I don't know. It may be an awning window for ventilation. But yeah, the use of skillion roofs and a great deal of glazing enables that extensive sun access to the northern side of these buildings. Also, top right hand tile here. Has anybody been to Cooper Pedy? Anybody in the room? Yes, it's a long way out of your way, unless you're going to Alice Springs or so. Apart from that, yes, it's a very long way out of your way, but a very interesting town to visit. But there you have plenty of people living underground as a good approach to dealing with the climate there. Incredibly hot, but living underground you get a very constant temperature from the earth. I think about 19 degrees. So, this is an excerpt from the National Construction Code. So these are our climate zones within South Australia. We have, as we get higher in number, we get cooler. So we've got climate zone 6 up around the hills of Adelaide, and then climate zone 5 through the plain. And so that includes down to the city of Onkaparinga area in the south, and I think it's Wakefield up in the north, right north there. So that's Gawler. That's the township of Gawler just there.
These slides are not heavier.
No, they're not. No, you'd like to be able to get them much larger. Yeah, but that climate zone map, you can see that from getting the National Construction Code, and then looking at that in detail from there. So we have it, and climate zone 6 includes Kangaroo Island, and then through the southeast, so along Coorog and then down to Kingston Road, etc., all the way down to Mount Gambier. So that's climate zone 6. So the reason we have different climate zones is because we have different requirements for heating, cooling, and insulation within those zones, and then we need to design those buildings differently. Typically, within the National Construction Code, that deals with different requirements for insulation. So as I mentioned earlier, thermal mass can be a real blessing if it is used in the right way. If we give it access to sun during winter time and keep it shaded during summertime, it can be a real benefit. So bottom left-hand side of this this screen here, we've got fluctuation in temperature throughout the day of various different building forms, and our major fluctuation there is our outdoor temperature. So top, we've got our outdoor temperature, that's what our outdoor temperature is doing. Light timber framed building is tracking that relatively well. So there's not a great deal of difference between your light timber framed building and your outside temperature. I think intuitively many of us would know that if we've spent any time in a fibro shack. Whereas a heavy building with external insulation, that's smoothing that curve significantly.
So what would be classed as a heavy building?
Heavy building with external insulation, that would be your cavity brick construction, rammed earth construction, masonry, mud brick, that type of thing. Although exactly where a brick veneer building fits into this, I'm not sure. I wouldn't classify a brick veneer as a heavy building with external insulation, because typically with brick veneer your insulation is internal, your thermal mass is external. So it's sort of working opposite of that. So and on that, is everybody aware of what is known as a reverse brick veneer, and how that works and how we use that? So I'll just draw it up quickly. So drive around the suburbs, the vast majority of buildings, if you were to slice through them, they give you something like this. So this is our slab. We'll have our brickwork, our skin of brickwork here. So our veneer of brickwork, timber frame, like that, ties into brickwork. This is the external, so internal, external. So with this scenario, and then we put all our insulation in between our studs here. On the outside of our building, that's where we have all of our thermal mass. Well, we've got thermal mass in the slab. That's fantastic. A lot of that thermal mass is inside. But a great portion of the thermal mass is in the brickwork, which is on the outside. And then we have our insulation in here. We're not really making use of that thermal mass properly. When we have reverse brick veneer, we'll have a scenario of our slab. We will construct. Now it might be brick, it might be concrete formwork. It's some sort of solid, high thermal mass material that goes on the inside, and then we'll have our stud work for the outside of the building, and then some sort of lightweight sheet cladding on the outside, and our insulation there. So that's tied back. So this is doing this is supporting our load, and that stud work is supporting our load. The bricks in both scenarios are doing nothing in terms of supporting load, but this puts our thermal mass on the inside of the building. So it just introduces that thermal flywheel to the building. And also another way of doing that is the last one on the bottom left here. Heavy buildings set into and partially covered with earth. So does everybody know what an earthburn house is?
What? An earth what?
Earthburn house. Or
So
earthburn construction.
Like half of it's underneath the ground.
Yeah, exactly. So, so has anybody heard of earth ships? Got a few nods from earth ships. I'd suggest you have a look at that yourself in your own time. It's not a form of construction for everybody, and I guess essentially there are different ways of going about it. But probably our most famous earthworm building in Australia is Parliament House. So that's a building which is set into a hillside, grass over the top. Yeah, it's a bit of, I think just recently it's you're not allowed to play on those lawns anymore. I think the rule is typically, plenty of people used to like to go up to Parliament House and muck around on the lawns that actually cover Parliament House. You can't do that now. But that is an earthworm building where we have, let's say we've got a nice sloping piece of land, and that's north up that way. We can cut into the ground, build a house, have lots of glass here, like that. Might even have a roof in that sort of scenario, so like tilting up. But then we cover the roof, grow plants and things like that on top. We end up having a house which is set into the soil that creates that thermal flywheel. So that's our scenario here. So this is this building here. So it's a heavy building set into and partially covered with earth. And then in that way, summertime, adequate eaves, don't get any sunlight onto into the building, but then in wintertime, plenty of sun into that building, giving us that extra bit of heat. Yes.
This thermal mass thing here, it's got water, 4,186. What's is that water in the walls or in the floor or what?
Well, that's just water as a material. Yeah. So we'll move on to that top right hand portion. So thermal mass as per material per volume. So what we've got, it's kilojoules per cubic meter, like possible energy storage. So water has the highest at 4,186. There was maybe it was on Australian Grand Designs. It was on one of these design programs. I saw there was a house designed by an engineer up in Stonyfell, so just up above Norwood there. He designed his house around a water tank. So building a water tank as the internal structure of the house, and then it went out from there. That scenario gathers a material which is on our table the highest possible storage of, or has the highest thermal mass to it, puts that right in the centre of the building. So it produces that thermal flywheel to the building, and also stores water, so provides water storage. I think basically the principle, to put it simply, what he did, it was a square water tank. It's going to be much easier to build around in that sort of scenario, and then a roof that's doing this, setting it into there, and I guess then there's some sort of very secure overflow scenario that goes out under the building. But then this is our building cross section through, and so great source of thermal mass in the centre of the building, producing that thermal flywheel. But below that, or half of that, is concrete. So if we can introduce a lot of concrete to a building, has a high thermal mass, but it also has a very large embodied energy as well. So there's a lot of electricity which goes into the production of concrete, or the cement that's required to produce the concrete. Unless we use things like, there's surplus cement. So there's the giant concrete blocks you get. So from people who do casting, with all the remains of their concrete, they just chuck it into these forms to produce large concrete blocks. Has anybody seen any of those about the place? Yeah, a few nods on those. So that's a form of huge amount of thermal mass there, but it's actually essentially a recyclable or waste product repurposed. Sandstone. So Yeah, we still mine and mill sandstone in South Australia. Basket Range sandstone is a good example of that. So we've got 1800 kilojoules per cubic metre. Compressed earth blocks. Has anybody seen a house done with compressed earth blocks? Yeah, I haven't either. I've seen in there's a Owner Builder magazine in that. I've seen advertisements for the tools required for making your own compressed earth block, but I haven't actually seen a house done
Mud bricks.
with it.
Yeah, is it?
But it's not mud brick. No, so you get, but it's essentially you're getting something very much like mud. Well, it's like a masonry form of rammed earth. So
Like dirt and straw. Coal.
No, it's not. No, it's not coal. So and I'm not exactly sure what you put into a compressed earth block. I don't think you'd want to put any straw in there. I think it works very much the same as rammed earth, but I have no experience in it. But basically, it's you've got a rigid steel small formwork that you place earth into, and then this long arm that you pull down, and that compresses the earth and makes a block. So it makes a masonry block with little addition of cement. So just using dirt for it. So that's compressed earth blocks. Slightly higher thermal mass than rammed earth, only very slightly. Everybody knows rammed earth as a building material. Add to that, there's rammed earth, and then there's rammed limestone as well. And yeah, rammed limestone can be a very nice effect as well. It's like that lighter colour. So you crush up the limestone and then just put it in the steel formwork and ram that as well. It bonds very well together. So FC sheet, that's compressed fibre cement sheet. So per cubic metre it has a lot of thermal mass, but of course it's utilised in thicknesses of 3mm, 6mm and 8mm, or sometimes 10mm fibre cement sheet as well. So typically you don't use much of it, so it doesn't provide much thermal mass. Brick, 1360 adobe, so that's your mud brick. It's at 1300, and I imagine cob is going to be pretty much the same as that, very similar materials. And then autoclave aerated concrete at 550. Everybody knows what autoclave aerated concrete is?
Is that the Hebel?
Yep, the Hebel.
I thought that was actually meant to be better in thermal properties.
So yeah, and that's the thing of, I guess, essentially unpacking the marketing around. So thermal properties, yes. What aerated concrete is good in is it has a higher R value, and I can't think of the your typical R values for the thicknesses of your sheet, but it provides insulation. So that table up there is dealing only with thermal mass, and so it tells you how it works as a heat store, but Hebel also works in insulation as well, so stopping the passage of heat through it. So for a scenario like a floor, it can be a fantastic way of doing an elevated floor, because it provides you with some thermal mass. You can get some sunlight in onto it, and it provides some warmth during winter. But then it also insulates between top and bottom floor as well. So it has several beneficial thermal properties to it. But as with any, I guess, essentially any virtue of a material, it all depends on the context of its use. So I visited a rammed earth house once in the morning, and it was shocking because of the use of rammed earth for external walls on this building. Yes, rammed earth has a low embodied energy, so that's certainly a virtue, but it has very little insulation capacity, so it transmits heat really well. And then also, once you put that thermal mass on the outside of a building, that that thermal mass doesn't give you much, I guess, much of the thermal flywheel effect for the building in the morning. So a material that has its virtues doesn't work well as an external wall because of its insulation, and then you're not also utilising its virtue of thermal mass. The same addition of a rammed earth wall, if that just runs through the centre of a building, and then you build around that rammed earth wall, well then that's fantastic. It's getting the thermal mass inside the building. You don't have to worry about insulating between one portion of the building and the other. But then you also have a very low embodied energy for building as well. So it's a way of getting thermal mass with low embodied energy. So that's the same material used in different scenarios has a very different effect on the comfort of the building and
Is
the
that
eventual energy
with
use.
straw bale walls?
What's that?
Straw bale walls.
Well, typically, so straw bale is essentially yes, it's essentially insulation, and it's a very environmentally friendly form of insulation because it can be composted at the end. It can return to, it's just straw. It can return to the earth. Unlike your mineral walls. Well, I guess mineral wool sort of comes essentially from the earth, but there are certain things tied in with that. But then polystyrene and polybats, etc. Or styrofoam, you have to deal with that later on. Straw bale is a massive, big, thick insulation block that insulates a house well. And insulation, pretty much in any context, is a virtue. So, not many scenarios I can think of where you could use straw bale incorrectly. As internal walls, maybe, because you don't need a lot of insulation inside a house. But if you start having walls this thick inside your house, you lose a lot of floor area. So, per footprint of your building, maybe that's a poor use of straw bale. As I said, typically thermal mass can be an issue if used incorrectly. So various forms of insulation. So this one top left hand, that's like an air cell type insulation. So there's quite a few products like that getting around now. That's a combination of a sarking and an insulation. So it's a building wrap, but it provides insulation. Typically they're only providing an R value of around 0.5, maybe 0.7. So it's only in addition. Typically, I think in climate zone 5, you might need R value 4.5 to 5 for your roof, depending on your roof colour. So an R value of 0.5 for your air cell is not going to contribute a lot to that. You're still going to have to do bats and things like that. But that sort of thing, I just put it in a shed. So built a shed, use that in the shed, fantastic. So where you're not going to, and there are no requirements for insulation, and you're not going to put bats, roof bats or whatever into a shed, but to have an insulated sarking like that just provides a lot more comfort in the shed, and although it's fairly low R value, it stops a lot of that radiant heat that comes from the roof. So you've got your reflective foil on the top, and so you're not getting the heat from your sheeting inside the shed. So great application for that. But also looking at it, I was looking at that for a raked ceiling, where so if you're doing raked ceiling like this to achieve an R value of 5, we're only dealing with 190 millimeters here, but we need at least, for our bats, need at least 350 millimeters to achieve that R5. So we've got roof sheeting up here, or we've got purlins, roof sheeting. There's just you know, our insulation bats would be coming down here. There's really just not the space for that. So what we can do is find out, you know, what bats can we get that fit in that 190mm area like that. So we've got insulation bats, we get an R value of, let's say, 2.5 from that. Then there's insulated plasterboard. We can get an R value of, I think, about 2 from that, so R 2.0 from our insulated plasterboard. So that's that thermoset foam with a layer of plasterboard on that. So it's in several layers like this. So that goes on the underside of that, and then we put in our insulated sarking up there. You know, 0.5 for that. Got a total R value of 5 for the system at the end. So it can be very handy for use in that sort of scenario if you want to achieve a rake ceiling but have that insulation there. But certainly by and large, your cheapest way of insulating is that bottom left tile there, the insulation bats. So where you can get bats into provide you insulation, that's going to be the best way of doing it. On the right hand side, the fella there is pumping in recycled newspaper. So that's the cool or cozy insulation. I know some people have poo-pooed it. I guess don't like it for working in the ceiling afterwards. I typically, I'm not sure if all that criticism really sticks. I still like the product. I think because it forms around your ceiling joists really well and locks in there, so you don't have gaps.
But how do you go then with downlights and exhaust fans and stuff
Well,
like that?
yes. Well, then you have issues with those. So yeah. So for an exhaust fan, you'd want a shroud around that, so you've got space around your exhaust fan. Downlights, yes. Not sure how you work with downlight in that scenario.
Because with the old downlights, the ones that aren't LED, they would just burn up there.
Yes. So it has fire retardant in it, but yes, that would certainly make me incredibly nervous.
Yeah.
A scenario like that, recycled newspaper in your roof at a downlight that's producing lots of heat. Yeah, that's a very good point.
What about that spray insulation?
Spray insulation, is that the
one where you do just sprays and then after a while it just expands outwards?
So that's the foams. So
Like on shipping containers.
yes, there are several different types of those foams. One is you got I don't know a lot about them. So you've got fire resistant foams, which are it's used for insulation where you also want it to be fire retardant, and that's the the two components are mixed together, sprayed on, and just expands because out like this and fills up gaps. I know a fellow who does refrigeration work for shopping centres with so running large pipe work in conduits that provide refrigeration, and then in those conduits he just these two components pours it in there and just goes fills out. So you've got those types of foams that provide a rigid foam insulation. But then there's also ones that are oil based as well. So they use so there's one that's called soy foam, which they extract oil from soy, and then that is used with some other catalyst to produce this expanding foam that's sprayed between your studs or your ceiling joists. That's relatively new. I don't know of anybody doing it in South Australia yet, but there may well be. But that I think is a very good form of insulation as well, because like the recycled paper, it fits around all your timber elements really well, and so you don't get any gaps in your insulation. there is, so when we talk about insulation, we're concerned with the R values of that insulation and the R value that's contributed. Here is a diagram showing the R value of various materials. So 90 millimeters of rock wool there, we get an R value of 2.5. Cellulose fibre with 100 mil, 2.5, etc., etc. So your various different types of bats. Uninsulated brick veneer still gives you an R value of 0.5. So R refers to restriction, so the restriction of heat flow. Brick veneer with a reflective foil gives you R 1.6. So there is some R value within your building fabric as well, which needs to be taken into account, which can be taken into account. So over here, the autoclave aerated concrete with a cavity has an R value of 1.6. Mud brick or rammed earth R value of only 0.4. And that's what I was talking about with that rammed earth house that I visited in the morning, being really, not being a great heat store. Very low R value, so it transmits lots of heat through it. And so the National Construction Code has requirements for insulation of buildings. And so there were times when the National Construction Code didn't have those requirements for insulation of buildings, and you could build things up, like rammed earth walls or solid masonry walls without insulation. Now they need to be insulated.
Do you know the R value of a double brick wall?
No, but it wouldn't be. It'd be pretty similar to this. It wouldn't be too dissimilar because double brick doesn't have a cavity in between it. It's just solid masonry that would transfer the heat. Although you've got uninsulated cavity brick, R 0.7. So that's But I mentioned double brick would be less than that, so probably more like this one here. Also, another important consideration, yes, windows are fantastic on your northern elevation for getting warmth during winter time, but it also has to be understood within the context of the fact that this glass has such little R value, such little insulation component, even when double glazed. So double glazing, yes, it's of a benefit, but still provides you less insulation than a wall. So 10 times more heat is transferred through a window than through an area of insulated brick veneer the same size. And here is a rough guide, a rule of thumb of your breakdown of location of windows. So how much window area? So north, try to achieve around 60%. Is there a limit? Was that? No, there's not a limit. What there is
you have to meet a certain R level. If you go higher than that, it's kind of hard to do.
you've got to meet a 6-star energy rating. And that energy rating is done through computer programs that simply look at the orientation of building, the materials, the placement of windows, and the insulation. So it takes into consideration all those factors and says, okay, and it determines your energy rating for that. And so if you've got, let's say, only 30% of your windows facing north and 60% of them facing south, you get these things around the wrong way, or you've got 50% of your windows, let's say 80% of your windows on the west because you're building on the esplanade and you want to look out and see, it's all great. You're going to struggle with getting a 6-star energy rating for that building because the placement of your windows is putting so much heat or cool load on your building that has to be counteracted by air conditioning or heating, that your building is going to use a lot of energy in counteracting that. So the computer program that's assessing your building is not going to give you that 6-star rating. So although there are not, you're not required by the NCC to meet any of these sorts of things, you're not going to make the energy rating if you step too far outside of these rules of thumb. So north 60%, south 30%, east 15%, and west 0 to 7%. You don't want a lot of windows to the west, typically for a comfortable building. Although, yeah, still I've seen some, and I don't know, I don't know the ins and outs of how it happens, but I still see some shockers being built as well. I was at a place in Mawson Lakes above a shopping centre. Massive windows facing west, dominated. There's a very tiny apartment, really big windows facing west. Like, it would be like a solar oven in a summer evening. I don't understand.
Is that legal though?
Well, yeah, I don't know how some of these things get through. Honestly,
You know, you talk about all these standards and
yes,
everything else. Everybody's got to kind of abide by the same rules.
yes,
But then you said you've got places that are
yes, and whether, and you've got aspects of the National Construction Code that I guess leave you financially, financially exposed. So you build a staircase in the wrong way, somebody falls down there, they can sue you. That's, your staircase wasn't compliant with the National Construction Code, caused injury. That's a very clear path to some litigation. In the terms of your placement of windows, or whether somebody in the building process did the energy rating report, what is your avenue for litigation there? I think it's a bit cloudier, possibly, and that's and it's certainly not the right thing to do, and it still leaves you exposed as a builder or designer. But it's but they are you break the law, and the law is only as powerful as the application of consequences.
So would a big veranda on a western side compensate for having
Certainly.
windows on
Yeah.
that side?
Yeah, certainly. Yeah. So large. Yeah.
Al fresco or
Yeah,
veranda
exactly. Like a big pergola. So let's say we've got our flat piece of earth, our house here like that, and our sun from morning through to night, midday here, 3 o'clock, 5 o'clock, 7 p.m. Let's say early April, something like that. Then, so we've got our glass window facing west, so west in this direction here like that. So that's the evening sun. So with no shading, 3 o'clock, we've got stacks of solar penetration into the house. 5 o'clock, basically, it's a wash with evening light. Yeah, it's an oven. But if we put a pergola out there like that, or even slightly lower like that, to that side, still at 5 o'clock, where or to the underside of that, let's go. Underside of that, we really minimise our heat, our light getting into the house, and then we're only sort of getting that full wash of sunlight from around, let's say 5:30. We're getting the full wash of sunlight, so as opposed to from 3 o'clock in the afternoon. So we're cutting down our period of full sunlight into the building by providing shading to the west in that fashion. So here are some useful links for you at home. So Sustainable Energy SA.gov.au. What was that? DPTI, SA, planning home, and your home. So your home is one that's referenced a lot within TAFE and the slides. Okay, so that's the end in terms of design considerations. Any more questions or additions people want to make? And how are people doing with the assignment? Are there any questions and queries in regards to the assignment? All progressing well? Well, yeah, if you are having any issues, by all means, let me know.